Guys, don't let me forget to keep holding this and talk, because last time I didn't talk with it and it just sounds like muffled. Anyways, the second video I'm filming is on the fundamental theorem of algebra, which is not really a necessity to know. It's just, it would have helped me a lot if not really. All it states is that there must be n's. So if you have a quadratic equation, a cubic equation, a fourth degree polynomial, fifth degree polynomial, whatever the exponent is, there are that many roots, or dare I say solutions, but there are that many roots as to what x can be. For example, for quadratic equations in the parabola, there are two solutions for what x equals, whether they are complex or real. That there's still two solutions. In cubic equations, there are three, and then in quartic there are four, and another. So it'll just help you establish things when you first get an equation. If it's a very long one, you can establish, okay, the leading coefficient or the leading variable is to the fifth power, so I know there are going to be 5 roots that this could be, right? Another concept is that complex roots always come in pairs where they are conjugates to each other. So that's what it sounds like. If you have I'm not sure why, but if you have a quadratic equation, you are either going to have 2 real solutions, or, okay, there's 3 options actually. You can have 2 real solutions, 1 solution, or 2 imaginary solutions, right? You're not going to have 1 imaginary solution and 1 real solution, because they're not. It just doesn't work like that. They have to be on the same y level. It wouldn't work like that. So you're either going to have 2 in sets of 2. So if you have a quartic equation, you can have 2 sets of real numbers and 2 sets of imaginary numbers that are the roots, but they're in sets of 2. So in a quadratic equation, if one solution is real, the other one is going to be real as well. Of course, unless your whatever it's called, discriminant equals 0, then it's a whole thing. There's only one solution because it's on this. But for the most part, in sets of 2. And so if you have a cubic equation, one solution can be real and the other 2 can be imaginary. They have to just be in sets of 2, though. Being said, you can also have fourth degree polynomials with no real solutions, sixth, however many you want. Like, if they're even, or even if they're in sets of 2, you can have a 7th degree polynomial where 3 of those sets are imaginary roots and 1 is real. 1 equals like 0 or something. That's just that. If you understand that, it's very easy. And it doesn't really help, but it just kind of like makes you like, oh, okay, that makes sense. That makes sense. And it can just help you pick apart equations when you first see them. You're like, okay, so here, first of all, right off the bat, seeing this equation, I know there are going to be 7 solutions, or 7, no matter if they're imaginary or not. I know there are going to be 7 roots this could be. Again, don't know why this happens. I'm just the messenger, bro. I just don't shoot the messenger. Okay. I'm trying to get, I will have my big video up. I think it's radicals explained, possibly. I will have that up before I post these videos. Trust. Peace out, guys.